All right, I said I'd make a quick recording of this problem. It came up in class. I said I would do it, and then I thought, no, I didn't want to waste class time doing a homework problem, especially when you've got hints what on how to do it. I like this problem because what you have to do is you have to do science. In other words, you have to kind of fish around and figure out what it's asking, and then you're taking a measurement of something else to figure out what the measurement of the other thing is. Okay. So anyway, here's what we're going to do. It says a tungsten wire of a certain radius is heated. Okay. So first of all, tungsten has a room temperature rho naught of tungsten is, I'm looking here, is 5.6 times 10 to the negative 8 ohm meters. Okay, and we're going to heat this thing up. All right, and what we're going to do when we do this is we're going to heat this thing up, and we're going to figure out what the rho is, the resistance when it's heated up. Well, already we know what the resistance is when it's heated up, and then we're going to figure out what the resistance is when it's not heated up. That made no sense. Well, here's what we're doing. Look, so we heat up this piece of tungsten, all right, and so we've got this V is equal to IR, all right. And this is when it's hot. V is equal to IR when it's hot. So we go, okay, well, then V is 180, which is equal to 1.6 amps times R hot. And here's what I get. 180 divided by 1.6 is equal to 112.5. So the resistance when it's hot is equal to 112.5 amps, okay, or ohms. Well, R hot, so now we've got to figure out, well, then they want to know how long the wire is. Well, look, the length of the wire is equal to rho at room temperature. Is equal to R at R naught, which is room temperature, which is equal to rho at room temperature, which is equal to L, the length of the wire, divided by the area. Well, they gave us the area. It's this dinky little area here. But you might be going, well, how the heck do we get this then? Well, here's what we do. We know that R hot, which we've already got, R hot, which we already got, is equal to rho naught, okay, is equal to rho naught times 1 plus the temperature coefficient of resistivity, which is alpha, times that change in temperature, which in this case is 1411 minus 20. Hey, do I have numbers for everything here? I mean, do I have numbers for everything there? Well, hell yeah. And so, can I find out what R naught is? That's not hard because I know this guy and I know this guy. I mean, I don't know this guy, but I know all this. So I can find R naught without much trouble. Do I know what rho naught is? Yes. Do I know what the area is? Yes. Find the length. Okay. So you had to kind of reverse engineer it. Basically, you had to go, okay, well, here's R naught, and then just do it. That's why I like this. That's why I picked it. I knew it'd cause some. I know it would cause people to scratch their heads, but that's a good thing. That's a good thing. So that now you can solve for R naught without any trouble, and then plug it back into here, and then solve for the length, and you should be fine. Okay. All right. So out here.